Solving exponential equations with logarithms. Now, let's start with some easy logarithmic equations. Say 4 to the x power is equal to 8 to the x minus 4. What's the solution to this? Well, here's a solution without using logarithms. You can see that 4 and 8 are both powers of 2, so you can rewrite 4 as 2 squared. You can rewrite 8 as 2 cubed. And then the exponential rule is that if you have exponents like this, you multiply, so you get 2 times 2x, 2 to the 2x power, and 2 to the 3 times x minus 4. Now if you compare the left side and the right side, the base looks exactly the same. They're of exactly the same form. So the only way that these could be equal is when you have 2x exactly same as 3 times x minus 4. What does that mean? So you have 2x equals to 3x minus 12, and then if you subtract 3x both sides, you end up with negative x equals to negative 12, which gives you x equals to 12. So 12 is the answer. Now let me show you a second solution which makes use of the logs. In terms of logs, the way you do it is you take the log both sides, and when you take the log, it's good if you can take the log with a base that 4 and 8 can be easily evaluated to. So I think log 2 of 4 and log 2 of 8 both becomes 2 and 3, so log 2 is a good choice. So I'm going to take log 2 both sides. And then these numbers, these exponents, can jump over the log like a frog. And now you have x log 2 of 4 equals to log, this x minus 4 jumps over the log, so you get x minus 4 times log 2 of 8. Now because 4 is log 2 of 2, second power, and 8 is 2 of 2 to the third power, the logs cancel, giving you with 2x equals to 3 times x minus 4, which is same as this other equation you get. And therefore, after this, you run into the same kind of algebraic simplification, and that gives you x equals to 12. Now at this point, you probably don't see why using logarithms is any better than the traditional method or the previous method, just using the exponential rules. The reason that you want to use logarithms to solve exponential rules is because there are simply some cases where you can't use the basic exponential methods. So here's example 2. Say you want to solve 3 to the x minus 2 equals to 5. Now 5 has nothing to do with 3. They're not common exponents of anything. So here you can't use any of the previous exponential methods. So instead what you want to do is you want to take the log 3 of both sides. And why do I take log 3? That's because log 3 and 3 cancels, and you end up with x minus 2 log 3 of 5. And then finally, this is 2 plus log 3 of 5. So your answer contains the log. If you use your calculator, you can actually figure out what this is as an approximate value. So to use your calculator to find the approximate value, first you have to use the base change formula to rewrite this as log of 5 divided by log of 3. Let's see what my calculator says. It says 3.465. So it's about 3.645. So that's your approximate answer. If you want your answer in exact format, this will be your answer. Okay, so that's why we do need logarithms to solve all kinds of exponential function equations. Here's another example. Example 3. Suppose you have e to the 2x minus 3e to the 2x, e to the x plus 2 equal to 0. What would be the solution to this? At first, it's hard to figure out what to do, but if you remember that e to the 2x is really e to the x squared, then you can see that this equation is a quadratic equation in terms of e to the x. So we can use this change of variable t equals to e to the x and rewrite the above equation as t squared minus 3t plus 2 equal to 0. Now this is a simple equation that you can factor it as t minus 2 times t minus 1, and therefore when you set t minus 2 equal to 0, you get t equal to 2, whereas t minus 1 equal to 0 gives you t equal to 1. But wait, this is not what we are asking for. We are trying to find the x value, not the t value. So once you solve for t, you have to go back to your x. T is equal to e to the x to figure out what you're really getting. So e to the x is 2, e to the x must be 1. Okay. Now in order to solve this equation, you have to solve each of them individually. Let's first figure out what's the solution to e to the x equal to 2. We should take the log with base e to cancel. This e is called the natural number, 2.71828 something, so it's just some constant, just remember that. They cancel and you get x equal to log base e of 2, and there's a common shorthand for log base e, which is called the natural log, ln of 2. That's what you get for this first case. Now for the second case, e to the x equals to 1, do the same, take the log base e. Log base e of x is log base e of 1. They cancel, you get x equal to, so you get log e of 1. But log a of 1, if you plug in 1 to any kind of log function, you always get what? Get 0. So 0 is the answer. Therefore, your final answer is that x is equal to ln of 2 and also x equal to 0. That's the answer for this equation.